Welcome to episode 16 of The Lowdown Show. I'm Neil Graham. Let's talk improbable career arcs. Chloe Lerin went from studying engineering in France to working at John Deere in Iowa to developing powertrains for Harley-Davidson in Milwaukee. This week we talk bagger racing, data acquisition, and the future, yes, the future of internal combustion. But before we dive in, a word from our sponsor. eBay Motors is here for the ride. With some elbow grease, fresh installs, and a whole lot of love, you transformed 100,000 miles and a body full of rust into a drive that's all your own. Brake kits, LED headlights, whatever you need, eBay Motors has it. And with eBay Guaranteed Fit, it's guaranteed to fit your ride the first time, every time, or your money back. Plus, at these prices, you're burning rubber and not cash. Keep your ride alive at ebaymotors.com. Eligible items only, and naturally, exclusions apply. Shall we take the plunge? How does a young woman from France end up working for Harley-Davidson in Milwaukee? Just can you take me through that arc of how you ended up there?
I went to engineering school in France, and one of the requirements to graduate with your engineering degree in France is that you have to have some kind of a validated English level. And so what schools do is they send you to either to do a full semester abroad between year 4 and 5, or in the case that I did something a little bit special called an apprenticeship, where I was somewhat sponsored by a company, kind of like a long co-op. And in this case, I had to do a 10 weeks internship in a foreign country. So because I was sponsored by John Deere, the choice was pretty easy. And they're like, hey, well, we're going to send you to Iowa. And there I went in January of 2014 to Iowa, to basically the mothership of engine development at John Deere. And so that's how I got to the US. And then it's like the rest is history. I just liked it. Figured that I could do my last year of engineering school all in the US. So I did an extension semester in Michigan, and then went back to John Deere again in Iowa for kind of the last bit of that long co-op and to validate my degree. And I applied to grad school and ended up in Wisconsin. And so from grad school in Wisconsin to my professional life, I created a network really mostly based in the US. And I started working for a company called Cummins that makes heavy-duty engines.
Of course, yeah.
And always wanted to work for motorcycles. I tried to go back to Europe, actually. I tried to work for BMW, tried to work for KTM. For some reason, never worked out. And so I found my way to Harley-Davidson, specifically because I was at a racetrack in 2020, I think. And we were at MotoAmerica, and at the time I was living in Tennessee. So we were in MotoAmerica, and I have two coworkers that I knew from grad school or current coworkers and former friends from grad school that were working for Harley. And they're like, hey, what's your visa situation at the moment? Like, we are looking for somebody to hire in our team. And that's where I went. So I finally ended up in the motorcycle industry, but not in Europe like I thought I would.
I think you have probably seen more of America than most Americans, by the sound of it.
I've seen a lot of it.
And typically when foreigners come to the U.S., they end up on the coast, either the East Coast or the West Coast. I mean, you've like bitten off a big, like Iowa, and yeah. A smart ass could make a quip from going to John Deere to Harley-Davidson.
Yeah, we're still racing tractors. I'll make it.
Your words, not mine. You're listening to The Lowdown Show, presented by advrider.com and supported by ebaymotors.com. Now let's back up even more. What led you to be interested in internal combustion engines or in engineering? Did you come from a mechanical family? Were your parents into things, or relatives? I mean, how did you take this career choice? What led you there?
So somewhat. My parents are farmers. My mom actually is a farmer. She grew up in Paris in the city and wanted to be a farmer from a young age. So she met my dad and they started a farm. But my mom is the head of the farm. My dad has a job on the side. So I grew up around tractors and machinery, but with honestly really no interest in taking over the farm or anything like that. It was just kind of an environment that I was in. I actually grew up doing judo, which is a martial art, and I wanted to go into the French military. I wanted to go into the military, then I wanted to go to the Air Force, and I went to military high school and kind of realized that following orders was really not my thing. I like wanted to be more of a free thinker.
Right.
And so I was like, well, I'm not going to be a plane pilot, but I'm probably going to be building planes. So went to engineering school at first, really because I wanted to build planes. Did my very first internship in a company that was making aircraft engines. Kind of discovered the basics of thermodynamics at the time, and then went way into engines. I wanted to just learn more about what made the engine, what made the combustion. So the whole path was kind of a funnel. Started with aircrafts and engines, then combustion, and now we're just working on smaller engines and performance. But I was really just like starting from a general idea of liking things that moved down to just a topic that was really interesting to me.
Most of us think of Harley-Davidson engines as being, at least as motorcyclists, we think of them as being large engines. But I guess if you come from the diesel, the John Deere world, I guess, or Cummins, it's a totally different thing. But I heard you in an interview say, or in a podcast say that, there is this sort of bias that motorcyclists think that Harley-Davidsons are kind of crude, and especially people like me who like, Euro bikes and so on, Ducatis and Aprilias and so on. But I heard you say in a podcast that it's actually, they're quite sophisticated in getting the performance out of them, because you have, correct me if I'm wrong here, but you've got two pistons and one intake manifold.
Mm-hmm.
And so can you explain some of the in layman's terms, some of the challenges that exist in getting both, performance and emissions and, fuel economy and all those things that you have to think of out of a big American V-twin? What are the challenges as opposed to, say, a more sophisticated engine?
I mean, the first thing is they have the displacement of a car engine. They're pretty much, a 2-liter engine. So when you're displacing a liter per cylinder, you're doing a lot of work on that piston. You mentioned the intake manifold. So to me, the most complicated engines out there are the diesel engines. So whenever I was working at Cummins, you have to deal with very complicated design with a lot of after treatments. All of that needs to be taken in account when you're doing your calibration. But you also have a turbo, and you have to manage the turbo, manage the exhaust temperature to get the turbo to spool, but not too hot, not too cold. So a lot of complicated systems are around that. In that sense, a gasoline engine and the Harley engines are pretty simple, but they present a very different type of challenge, which is really understanding how much air we're putting in it, because you have, like you mentioned, a common manifold, and there is what we call a little bit of cylinder or fuel robbing, where you don't really know how much fuel is going into one cylinder or the other.
Right.
So we have to understand that. We have to understand how much air we're pushing into, how much air really comes back out, because there's so much dynamics into the manifold. So all of that is a challenge that I wasn't really prepared for initially, just because I was so used to being able to measure how much air goes into an engine. I might have mentioned before also the cam phasers. So the Revolution Max has overhead cams, which is a little bit more current as far as engine design go. But they have the ability to move the cam phase a certain amount of degrees on one direction and then the other. And so in some area of the operating map, we are prioritizing fuel economy, and then in another area, generally higher load, higher speed, we're trying to really focus on power delivery. So something like that is not really something that I've seen on a lot of motorcycles. The cam phasers are really something that you see in the automotive space, but I know the GSX-R 1000 has a cam that phases, but it's mechanical. It phases with the RPM as it increases, whereas the Revolution Max that's the engine that you find on the Pan America has phasers that you can independently control. And then the newer engine that we put out in 2024, I think, also has, in the Milwaukee 8, also has one cam phaser for all of the floor cams, or not the floor cams, sorry, the each push rod basically is activated by one cam that moves.
Yes, yes. It's interesting to me. I think that we're sort of at this, this point where, back in the '90s, I wanted to let me back up here a second. I wanted to buy sort of an interesting motorcycle. I love twin cylinder motorcycles. I wasn't a Harley guy, and at that point, you couldn't find Moto Guzzi's or Ducatis. They weren't around. And now, I mean, we're in this incredible place where you can buy, you can buy an Aprilia, you can buy a Ducati. There's so many the resurgence of European manufacturers. It's almost like we're at peak internal combustion. I mean, what you can buy in terms of the performance capability of the modern motorcycle is really astounding, isn't it? And it's almost like we're at the end of internal combustion, although that can be argued. And yet we have this incredible sort of luxury of what we can get. I mean, would you sort of agree with that? I mean, the marketplace is incredible with motorcycles right now, isn't it?
I think it is, but I think there's still so much to do. We've definitely picked all of the low-hanging fruits, but there's still so much to do. There's a lot, as far as new fuels, alternative fuels, and MotoGP is going that direction. Formula One is going that direction. There's a lot more. We're talking about AI right now and the computing power that comes out. There's so much more that we could do as far as engine controls and change the way the ECU is operating. I feel like there's also development in material science. And right now, so MotoGP, for example, the biggest thing that they're after is RPM, because obviously the higher the RPM, the more power you can make. And so they are really pushing the development of their valve train and their material that goes with it, all the materials that go with it. I don't know. The internal combustion engine for me is not dead, and it's still a very interesting tool. I think the regulations are going to push us one direction or another, but there's still a lot of work to do, a lot of integration to do. In my previous job in research, we worked on pre-chambers. And the idea with the pre-chambers was more for fuel economy, because you can increase the reactivity of the fuel, and therefore you can go a lot leaner than.
And can you explain what a pre-chamber is? What do you mean?
So there's different types of pre-chambers, but in this case, picture a little well around the injector and the spark plug, and you still have, in this case, you still had air and fuel from the port fuel injector coming into your cylinder, but then you had another injector and the spark plug injecting into this very small chamber, and the spark plug would ignite this locally rich pocket, and then outside of that little well, just picture a flamethrower. It's not exactly flames because we call it reactant. It's still a mixture that is reacting, and because it's reacting, it ignites the very lean mixture that is in your cylinder. And the very simplified way is just like picture a flamethrower outside of a little pocket, and it's pretty much like a diesel injector, but you're doing that with natural gas, you're doing this with propane, you're doing this with gasoline, and that really allows you to ignite the rest of the cylinder using very little fuel. So things like that really have not been explored in smaller engines, and we still don't have direct injection in motorcycles. So yeah, just a lot of things that we can do, I think.
Because there's, and I'm glad you've corrected me, because I've sort of been led to believe that sort of internal combustion is sort of everything has been done mechanically, and the only thing left really is through electronics and management systems. But you're saying that's not true, that there are mechanical things that internal combustion still can do to keep itself relevant. I guess that's the idea, isn't it?
It's the idea, and there's some kind of a Venn diagram for engines. You have when you're talking not about racing, but when you're talking about a production engine, you have, a circle that's going to be your fuel economy. Then you have a circle that's going to be the emissions. You could add a circle that's going to be noise, because noise coming out of the engine is something that is regulated. And then you'd have the other one that's performance, and then you have cost. And finding the area that intersects into that Venn diagram is really, really hard, and that's really where the challenge is. We've seen, development of engines in racing, and very easily, right? You change your exhaust, you gain more power. That's because we have to make compromises whenever we're putting out an engine for production, and it has to pass regulations. So whenever you start leaning into one direction rather than another, you have some really interesting work that can be done. Just focusing on fuel economy, you have a lot of things that are very interesting, but then that might come at the cost of adding some emission regulation devices. If you go towards power, you might not be emission legal or noise legal. And so finding the middle, I think maybe we've done a lot of what we can do within the cost that is bearable for customers. And I think that's where the limitation is. But as far as like the individual parameters, there is a lot that can be done still.
eBay Motors is here for the ride. This week's Fireside Chat is about data acquisition. Nothing makes a great story like data acquisition. I was at a press launch once, an Aprilia launch at Misano, and the bike was fully equipped with data acquisition. So everything from brake pressure to throttle opening to lots of other stuff that I can't even remember at this point. But near the end of the day, I thought I was going well for a man of a certain age with, modest capabilities in the saddle of a motorcycle. And I was feeling good, I should say, until the technician overlaid my data with the World Superbike riders' data on the same track. And well, this kind of sums it up. At one point, he was grabbing another gear and I was braking. So he's going faster and I'm already slowing down. And the thing about data acquisition is you can't bullshit. Like, it tells the truth. It's like a magic serum. And I don't want a magic serum. And now a word from our sponsor. With over 122 million parts, you can make sure your number one ride stays running smoothly. Brake kits, LED headlights, roof racks, bumpers, whatever your baby needs, eBay Motors has it. And with eBay Guaranteed Fit, it's guaranteed to fit your ride the first time, every time, or your money back. Plus, at these prices, you're burning rubber and not cash. Keep your ride alive at ebaymotors.com. Eligible items only. Exclusions apply. Now back to my conversation with Chloe. You're listening to The Lowdown Show, presented by advrider.com and supported by ebaymotors.com. What's a typical day for you, or what's a typical week, and what sort of work? What do you do really?
It's never the same, and that's what I like. For example, today I worked from home. I have a little bit of a special role in my team. So I'm part of a team called, actually it changed recently, it's Performance, Noise, Intake, and Exhaust. And so, as it's self-describing, right? There's people that are designing intake system, people that are designing exhaust systems, are responsible for the parts delivery. We're responsible for the performance of the engine, really kind of ahead of production. We, in general terms, basically will decide on a power level, make sure that it meets noise regulations, and then essentially define the architecture of that engine, and then we'll go with it for development. What I do specifically in that team is a lot of the, let's say, model-based calibration is kind of what it's called, or I build or help build tools for our calibrators. So a lot of the work that I do will be gathering a lot of data from an engine, and then through data processing systems, fit surfaces to try to optimize the engine calibration. So optimize towards lower fuel economy, optimize for a good mapping of the engine to have a proper throttle response, optimize the engine so we can map the airflow that goes into the engine. So it's a lot of data acquisition, data processing. You could simplify that saying that it's a lot of machine learning. And for example, today I spent an entire day just using AI tools to come up with a new code so that I could visualize data a lot more easily. So I'm trying to really integrate some of the AI tools that are now available into what we do. So it's kind of in the infancy phase, but I think there's tools out there, and we definitely need to investigate them. And then the second part of my job is I'm responsible for the testing and development of the race engine for King of the Baggers. So I work with a very talented dyno technician, mechanic. Really, I mean, he wears so many hats, but I work directly with him, and I essentially report my results to the race team. And we are generating the calibrations for the race engine. We are testing the new parts for the race engine. We are, I would say, what's the right word for it? Losing my word. Just generally giving directions and suggestions. There's the right word. We're suggesting the race team a direction to go with for improved performance, and we're doing a lot of the durability testing as well in engine dyno. So whenever we have a finished product, which is constantly evolving, so a finished product can be like every month or so, we generally give our package to the engineers of the race team, and then they put that into chassis dyno, test it, go to the racetrack, test that, and then eventually you'll see something in the Racebikes for King of the Baggers.
We'll get to King of the Baggers in a minute, which is a whole conversation in and of itself. Next to school bus racing, I think it's the strangest thing I've seen. But Harley, I think of all the motorcycle, at least as from the outside, I think of Harley as one of the strangest sort of companies in terms of mechanically, because things like the visual appearance of the engine and then in noise. Well, I mean, Harley at one point tried to trademark the sound from its exhaust a number of years ago.
I heard.
So it's the way an engine looks. I was at a Harley press launch years ago, and it was the last Harley press launch I was ever invited to, and I worked at a magazine. We had a few drinks, and somebody was talking about push rods, and I said, "Oh, overhead cams are just a fad," and I meant it as a joke. I don't think they took it as a joke, but you have this engine. It's it has to look a certain way, and seemingly, at least in the traditional looking Harley-Davidsons, it has to have push rods, and it has to sound a certain way. Because if it doesn't sound like a 45-degree V-twin, there's something wrong. So, I mean, you have so many parameters that you have to work with, correct?
Yeah, and it's the only engineering job that I've had where the appearance of the engine matters.
Yeah, like a Cummins diesel, they don't really they're not concerned what it looks like, really, are they?
No, it's red. It's going to be under the hood. A John Deere engine, it's going to be painted yellow. If it's for construction, it's going to be under the hood. It doesn't really matter. It's a structural point of the of maybe whatever vehicle it's in. But for a Harley, you see all of the engine. It has to be there. It's a piece of art. So as far as the design goes, it has to fit a package, and it has to be pleasing to the eye, to the ear. I mean, it has to appeal to the customer, and that's also the only job that I've had where the customer really matters. And as engineers in development, because I've only been working for products like way ahead of production, it's the only job that I've had where we take the input of the customer and then try to use it to define the direction of our products as far as sound, feel, look. I mean, we even have tests that are called like sound, feel, and look. Like we have listening sessions, for example. So your engine's not gonna sound the same if you're wearing a helmet or if you're not wearing a helmet, or if you're idling or if you're just passing by. So there's just so many parameters. It's this is challenging. I mean, how do you make a traditional looking engine pass all of those regulations as far as emissions and noise, and then still perform better than the previous version? So yeah, different challenges, really. Pretty interesting.
But from an engineering point of view, I mean, that must there must be moments where it's frustrating because you want to design. I mean, an engineer wants what they want. You want the most efficient, the most powerful, the most, and yet you don't get free reign, do you? I mean, it's not like, as you said, it's not like a Cummins diesel, or it's not like a John Deere.
I mean,
And Harley Davidson. I mean, I've often felt sort of bad for Harley engineers or designers, because whenever they've stepped outside of a certain range, I mean, the bikes where Harley has sort of over its history, where it's sort of attempted something new, like dealers hated the V-Rod, which I thought was one of the best motorcycle engines ever. I don't know if you've ridden one, but
no,
it
I
was,
have not had a chance now.
yeah, I think Porsche was involved in some of the design. I think with the cylinder head or something. I could be getting that wrong. It's a long time ago, but it was kind of I think the most charming engine I've ever ridden is the V, in terms of production bikes, is the V4 Aprilia. And the V-Rod engine wasn't far behind. It was smooth, but not bland. It was just this incredibly charismatic engine. And whenever I would speak to Harley dealers, especially back in the years when Harley was selling massive amounts of motorcycles, they just hated V-Rods. And I thought, what a shame, that anyway, you work for the company. We can't get into this, but the point being that you have so many parameters around you, and I mean, that must complicate your job immensely.
Mm-hmm. I mean, in any job, right? In Cummins diesel engines, you're still going to have to make some compromises. In racing, you're still going to have to make some compromises, and often in racing is going to be cost of development or time. So it is what it is, and it's what makes the job interesting, is that you have to optimize. And as far as what I'm doing in Engine Dyno with all of the optimizing tools and acquisition of data, that's really what we're trying to find. We're trying to find the best of however many worlds that we have.
When I first saw King of the Baggers, I thought it was the most ridiculous thing I've ever seen. And then, the more you watch of it, the more you think, well, this is actually kind of fun. And what those guys can do on those bikes, and the way they slide around, and, Jeremy McWilliams and your riders. And I mean, it's pretty incredible what they can do. And I think, from the outside looking in, you see the amount of development, and even I don't have a sense of how much money is going into this, but it's got to be huge. And the teams, my understanding, and I'd like you to talk about this, is that it sort of started out, and it was some Indian and some Harley, engineers and technicians, on the side, but it's really ramped up into really factory racing, hasn't it?
Yeah, so we, as Harley-Davidson factory team, are the only factory race team in the entire paddock. There is no true factory race teams in Superbike, for example. There's some factory supported-ish teams. And actually, even the Indian motorcycle team is powered by SNS. So there's a partnership there. It's kind of like if we had partnered with Vincent Hines for the racing. So yeah, I would say Harley-Davidson is a true factory effort. It's their own department in the company, or their own division, and yeah, I mean, everything is done in house. There's absolutely nothing that has been offloaded to a different company, except for whatever suppliers we have that are helping us. But it's 100% in house.
But I know you can't talk specifics because that wouldn't go down well. But the amount of performance that they get, I mean, are you even surprised at how well these things go? I mean, it's kind of astonishing. I mean, something that big, and anyone who understands, and I don't understand a lot of it, but just a rudimentary understanding of aerodynamics means that to push the size of the fairing, which is like the front of a Volkswagen, with those bags, I mean, it's aerodynamically a disaster. And yet the power and the speeds they can go, it's just, I mean, does this surprise even you?
Yeah, it surprises me. When actually we're going to Laguna Seca this week. So I'm headed there on Wednesday. It was 4 years ago, 5 years ago, 4 years ago. They had the very first King of the Bagger race, which was just an exhibition race at Laguna Seca. And I remember just seeing the Harley people in the paddock and just seeing those bikes, and they were loud and obnoxious. And I'm like, they just don't they don't belong here. And at the time I was working for just a small team on a Suzuki, I think. Um, and just 2 years later I get hired by the company, or not even a year and a half later I get hired by the company, and completely drank the Kool-Aid right away. But yeah, I definitely remember seeing the Hells Angels showing up in the paddock and be like, oh my god, this is different. And then I headed out to the corkscrew and saw those bikes going down, like, hey, actually this is kind of interesting. But at the time they were doing the lap times of the Junior Cup bikes, and the next season they're doing the lap times of the Twins Cup bike, and now they're on par with Super Sport, which is, I mean, incredible. The lap times they're doing for the lack of riders' aids, it's it is very surprising to me. And apparently, if you listen to some of the Cal Wyman and James Spoley, they'll tell you it's a very comfortable bike to ride. So yeah, I mean, what we've been able to do with it is crazy.
They look terrifying. I mean, as a sport bike rider, I look at those things and I think, my God, it'd be petrifying to ride them. But you're saying they work as racing bikes.
Yeah, yeah, yeah. They actually handle very well. It was a very interesting experience when we were at Circuit of the Americas for MotoGP, and they had their exhibition race over there. The amount of MotoGP teams and MotoGP riders who would go to the bagger teams and just like take a look at the bikes, and just they would pause and look at the Brembo calipers that we have on it, the types of brakes we're using, the wheels that we're using, and the swing arm design. And there's just, most of them would just pause and look at us and be like, those are true race bikes. They have the components of true race bikes. I mean, sure, they still have push rod engines, but NASCAR still has push rod engines too. So
and,
it is,
and they're so far off the ground you could walk underneath them, right? Because you need I mean, that's the thing that strikes you when you see them is this. I mean, I guess obviously cornering clearance, you've got to get them off the ground.
They have to, yeah. So it's all about that. I mean, you don't just go fast with an engine, right? You go fast with being able to carry that lean angle and be able to, just carry that corner speed. So, ground clearance is very important. There's just so many aspects of it. So that's I like to say, when you start working on a bagger, you have to pretty much throw away everything that you know about motorcycles, all of the numbers that you have in your head, and you have to only keep what you understand about motorcycles and about physics. And then you can start working on a bagger, because it is a motorcycle, but it's just so far of what we're used to seeing.
Can you get into that a little bit in more detail? I mean, compared to say a Japanese 600 or 1000, which is a very understood platform. At one point, all the Japanese 600s, when they made them, all had the same bore and stroke. Near the end of the at one point 10 years ago. So what do you mean by that? That you have to sort of throw what you know about traditional sport motorcycles to make a bag?
I'm thinking about a general chassis person who would come in and be like, all right, well, your suspension numbers have to be within, this stroke and that stroke on the front and the rear. And, the position mid-corner has to be this and that. Like, there's a lot of numbers that we're used to operate within when we're reviewing data, like the speed at which the suspension is moving, what we call the velocity. All of that is kind of different. You're seeing very different things. You're moving a motorcycle that's 640 pounds, I think, when it's full. So that's going to do very different things on the suspension. You're not going to operate within that same, swing arm length. They're motorcycles that are much, much longer. The tires are superbike tires. They're not going to perform the same way with a bagger that's 640 pounds as they are with with a super bike. So all of those little things where you're like, okay, well, swing arm length should be 560 millimeter, and then or velocity shouldn't exceed 600 millimeters a second. Like, that's, you're gonna have to throw that away and just start building your own database and understand the physics of what's acceptable. If you're looking at engine operation, it's generally the same, the airflow ratios at which you operate and all of that. But your maintenance, schedule is going to be completely different because the engines have not been built in the same way. They've not been built to rev really, really high, and they've not been built to last an entire race. So, I mean, as a matter of fact, the engines are being changed between races or during the race, during the race weekends. So, all of that is just, it's a completely different way of operating a race team.
I mean, one of the criticisms of racing, I mean, I love racing, you love racing, obviously. But one of the criticisms of racing is how do you quantify that investment of money? Because, of course, the bean counters want to know that and Harley is spending cubic amounts of money on bagger racing. But how does that equate both in terms of sales and in terms of product development? So can you give me any sense, of how the information that you glean from this crazy thing that you do in racing baggers, how does that filter down into production bikes? Now, I know it's only been a few years, really, and it's only been 4 years, so it's still early in the process of that. But what do you learn about pushing those engines so far beyond where their comfort zone is? I mean, are there things you can only learn in racing, or can you emulate this kind of use on a dyno?
It's really tough to say, well, King of the Bagger is responsible for that many more sales of touring bikes. We now have the CVOST that's really has been inspired from the effort of the King of the Baggers, and has the dual shock at the end with the two reservoirs. So we know from rallies, for example, with at Sturgis, Olin's just completely sold out of those suspensions because people wanted the same. They would show up with a picture of Cal's bike at the time. That's when he had the #1 plate, the blue one, and they would just go to Olin and say, "This is what I want. I want those shocks." We see the same thing with a number of people that are interested in racing in BRL, which is the club racing level. They want the same swing arm. They want the same parts. As far as exactly how many people are coming now into, like, new customers are coming into the company and buying Harleys just because of King of the Baggers is kind of tough. But MotoAmerica will tell you the attendance at the race rounds has greatly increased since King of the Bagger actually started. So it's bringing a new type of fans into
Hell's Angels, I hear.
There you go. But it's also, I think it's also creating a new type of motorcycle customers, like people who might enjoy racing and then want to go for something that's a little bit more comfortable but still has some performance. They know what those bikes can do, and then therefore, will buy one of those new performance baggers and then trick them out. We are learning.
I mean, it also makes sense to race what people buy, and the traditional sport bike market is, I mean, 20 years ago, the best-selling motorcycle was a 600cc Japanese sport bike in North America, and of course that's long gone. So yeah, to me it makes sense. Why not race? But from the second part of that question, from an engineering standpoint, applying what you learn from this, do you see applications directly into production motorcycles?
Yeah, we do in the understanding that we have in some of the durability items, and some of the performance as like performance parts that we've developed. A good example would be knock control strategy. So our engines are protected with knock sensors. We've learned some, I can't really go into details, but we've learned some stuff from just developing the King of the Bagger engine and then implemented that into the ECU strategy. So there are things. It can be subtle because it can simply be a change in calibration or the way the ECU is working, or it can be more of a durability item because we've tested those engines so much further than what they would be put through in the streets. But there is definitely a lot of things that are trickling down to the production space.
We'll have a bit of a shift in our conversation because you also have this other life where you work with a Team Hammer, US-based road racing team that races in MotoAmerica. And it's my understanding you're working with the super sport riders.
That's great.
And I think one of us one of the great misconceptions about racing that a lot of us who are huge fans of it, and who watch MotoGP or MotoAmerica or anything, is the rider comes off the bike, they sit down, they go to the seat beside the crew chief, and and they do this, or they do the head shake, or all the universal, or everything for chatter. And so, how does it take me through the process of what happens in your team? So the rider comes in, and the rider says something, and there's all these legendary stories of there are riders who are notoriously good at giving feedback. There are those who are notoriously terrible at giving feedback. How does that get shifted through? Can you give a couple of concrete examples maybe of what happens when the rider comes in, and how does that chain of control work? Because you don't have a lot of time. I mean, you've got another session coming up. Mm-hmm. And so, what's electronic, what's mechanical? There are so many different components on a motorcycle and so many ways to control it. Take us through that. How does that work?
It's part of the challenge. So I have 3 riders at the moment. I have all 3 riders that Team Hammer fields for Super Sport: Tyler Scott, Teague Hobbs, and Joel Ullman. And there's no 3 of me, so I can't be in all of the debriefs. So the riders will sit down directly with their crew chief and picture a qualifying session. There's a plan. They're going to go test a tire. They really are building this bike so that it will last the race distance. So they're trying a bunch of different setups. So each rider has their crew chief and their mechanics, and then we have one suspension technician for the entire team. We have the assistance of a Dunlop technician as well. And then there's me. So whenever the rider comes off the bike, mid-session, for example, he will really address what's the biggest problem. And generally it's going to be like a little suspension change, or maybe the engine braking is not good enough. So we just make those quick changes where, we're going to add a couple clicks of compression. We're going to maybe change the tire if he didn't like that tire. Or I will just advise, go to this different mode of engine braking that I mapped for them. That's, generally what we can do during the session. Then they come off the bike after the qualifying session, and they will offload directly with their crew chief, and they do this chatter here and then head check here and whatever. And we're still refining the process, but generally we try to stick them with the track map right away. Give us your hot take on what's really important. And then eventually they'll just go back to the truck, they'll get changed, and they'll be still thinking about everything. And so we'll give them the track map again, and then we'll ask them to go corner by corner. How does the bike feel? What's the most important corner? If we change something in one corner, how is that going to affect everything in the rest of the track? What's more important? Where are you struggling the most? What corners are good? And you don't want to change anything. That kind of gives us an idea of, how to prioritize everything. In my case, generally, because I can't sit down in all of the debriefs, I will take the track maps and then I will just grab them and ask questions after. If I don't have a track map, it's really, really tough to grab all the data and just fish for nothing or fish for something that I don't know. So I really work based on feedback and track map so that I can start addressing everything that I can address. So by reading data, I then communicate information to the crew chiefs. I communicate information to the suspension technician, and we review kind of the general setup of the bike. And then what I can do with the engine mapping is going to be throttle response, engine braking, shift strategy, things like that. Or sometimes I don't even have time to do that. I have to troubleshoot a problem. So Ridge, race 1 in Super Sport, Tyler Scott had a little bit of a problem. The bike was missing. He described it as the bike was missing. So, first thing we start thinking about is fuel pump, injectors, coils, like something mechanically is wrong, or the shifters, electronically something has to be wrong, like maybe the shifter is interfering. So, you start going through a process of elimination, trying to understand what's going on, really. And eventually you have to go with, all right, this is not this is not it, we've eliminated this, what else could it be? It happened to be an electrical issue, physical electrical issue. But that's like a big part of the job, is making sure that the motorcycle is going to be working for them. And yeah, I mean, there's so many things. Like, really, you're working on looking at data, comparing the riders, make sure that they're optimizing their way around the track. So throttle application, brake application, lean angle, line. If the line is not proper, if their throttle application is not deliberate, or something is hesitant, or one rider is better than the other, you try to communicate with them where they can be better. You ask them why they're not able to go to full throttle in some areas. They'll tell you, what the problem is. Then you start looking at the chassis. Then you start looking at the electronics. And that's kind of the first part. And then there's, like I said, the troubleshooting, and then just like little optimizations of the engine mapping. It's it's a lot, and honestly, every session is going to be different, because the problems are not always the same, because there's going to be problems that are going to take priority over others. Like I was mentioning, like an electrical issue, and it's all hands on deck. And then Team Hammer also has a lot of customers. So Team Hammer is the manufacturer for this throttle body conversion that is making the 750 legal for Super Sport Next Generation. So they've partnered with a company in England to make the electronics for it. And anytime that somebody is buying a Suzuki to race in MotoAmerica, they have to go through Team Hammer for this. So there's a lot of support also that comes with it. Just making sure that all of the customers are set up, that their ECUs are updated. Try to troubleshoot some of that as well. So yeah, it's just running everywhere. Make sure that everybody is sorted out. Make sure that all the information is communicated to me and then to the team once I've had the information and have been able to digest it. And then make sure to make a plan with the rider for the next session.
One of the questions that always incites the passions of riders, of course, is electrification. Mm-hmm. And for those of us who have a long history with internal combustion engines, we have a real affiliation that an engine is the heart of a motorcycle or car, and we tend to we have emotional, we have our favorites, and some like a screaming 4-cylinder, and some like a grunty twin, and it's such a it's the identity, and certainly for a rider my age, I don't have that connection with electrification. Mm-hmm. Now, I think another generations absolutely will. I mean, I think we have to have perspective, because I think 100 years ago you could buy, or 120 years ago, there was this point at which the automobile was going to be either gasoline, electric, or steam. So we've been down this road before, and and had we gone to steam, I mean, it would be a totally different conversation we'd be having now. But what's your response to electrification? I mean, in terms of so much of it is the same. It's just a different propulsion system, of course. Mm-hmm. But do you feel that emotional connection to electrification? Does it as an engineer, does it interest you?
It's interesting, and I'm preparing for it. I think the big advantage of what I do in racing is that data is data. There's always going to be some kind of engine management, whether it's thermal for battery, or it's just managing fueling. I think it's kind of the same issue, really. You're approaching it the same way, I guess. But there's still going to be a throttle. There's still going to be brakes. There's still going to be all of the sensors that we look at on a daily basis at a racetrack. So I'm not so worried that I'm not going to have a job or anything like that. But as far as the connection, I don't think I have that connection to electric engine. It's not,
so
obviously
you're an old soul, in other words, right?
Yeah, I do believe that I still have an entire career in internal combustion engines ahead of me, but I do really appreciate hybrid engines. I think are a really good solution that we haven't really been implementing in enough passenger vehicles, or it's not really been done on motorcycles, I guess, for a reason. I mean, packaging is always a problem, but I think there is something to explore with more of the hybridization. I think it seems like some car manufacturers are kind of getting around, kind of coming back to hybrids. So I'm kind of interested in electrical bikes, but it's not like I want to go. Like I wouldn't mind just doing it as a side project. I'd be very interested to learning about them, but as far as like, would I abandon my combustion engines? No, not yet. Not ready for that.
What's next for you in your career? You've moved around. You've done a lot of things. You've learned a lot of things. You obviously have the passion for racing, but you also have the sort of stability of a full-time, gig in Milwaukee. What's next for you, and where, you're still young. Where would you like your career to go? Where do you see yourself going?
It's interesting. I don't know. I'm open to seeing where it goes. I've been thinking about, just taking my little business full time and just consult for race teams and maybe open up to race cars. I've also been seriously thinking about what would my life look like if I were to go back to Europe, because I never said to stay in the US initially. And, could I make it to MotoGP? Do I have, at this point of my career, the question is, do I have the skills to now make it to MotoGP? So I'm trying to build my network little by little, trying to get to know the people that work in GP, in World Superbike, really try to see what the areas of interest are. And it seems like at the moment, it's a lot of chassis and aero. I wonder if there's going to be need for, engine development people with the direction that is going in 2020, or the fact that they're going to alternative fuels, which is an area that I've worked in quite a bit before. I'm also kind of really interested in the AI path. So what can we do? What can we do with AI to continue improving the motorcycles? And I know that at the highest level in Formula One, in some of MotoGP, there are just so many people that are crunching data and running simulations to see, all of the different behaviors of the bike, or what tire choice is going to be more beneficial for the race, etc. So, there's so many options, and because I have all of those hats of, I can do data review, I can do engine ECU setups, and I can do engine development. All of those roles are in the MotoGP team. They're 3 different roles. So I'm at the point where I don't know which one I should really get into the most. But so far, I really enjoy everything that I'm doing, and we'll see. It's been, every year has gotten better than the previous one, with just more learnings. I get better at what I do. My network grows. I get to help riders that are really better and better and better. So yeah, I don't know. We'll see.
In closing, a word from our sponsor. eBay Motors is here for the ride. With some elbow grease, fresh installs, and a whole lot of love, you transformed 100,000 miles and a body full of rust into a drive that's all your own. Brake kits, LED headlights, whatever you need, eBay Motors has it. And with eBay Guaranteed Fit, it's guaranteed to fit your ride the first time, every time, or your money back. Plus, at these prices, you're burning rubber and not cash. Keep your ride alive at ebaymotors.com. Eligible items only, and of course, exclusions will apply. Thank you for listening to The Lowdown Show.